So in this design, that means coplanar waveguide means we are placing the 3 strip lines on the same layer. So in between the feeding or excitation, that means the center is the excitation one. So the left side is the one ground, right side is the another ground. So in between excitation and left and right here, some space is there. That is the space is very little bit space. That is the narrow space. That means simply the coplanar waveguide. So coplanar waveguide is an alternative to microstrip and strip line. That means alternate of the microstrip feeding line that place both the signal and ground currents on the same layer. So that means Cheng Pi Wan invented coplanar waveguide in 1969. So that means simply, so we are placing the 3 strip lines on the substrate. So see the here, see this diagram clearly. So this is, that's why simply we are taking the one substrate. On the substrate of the layer, placing the left side is one ground, right side is another ground, center is we are simply giving the feeding technique. So this is the coplanar waveguide. This is the alternate method to give the input of the your design antenna. Is it clear? So now go for the design. So last week we are doing the rectangular patch. So in this week we are try for the another shape, that is possible try to the circular disc or circular shape. The last week I give you some assignment. Everyone done or not? Do you have any doubts in that previous design? So please respond. Why we are wasting the time? Already the 40 minutes is gone. So are you have the HFSS software in our PCs? Everyone, I hope install the HFSS software.
Yes, sir.
Yes.
Okay.
Yes.
So in the previous microstrip line feeding, have any doubts? Are done or not? I give you some work assignment. So design the different frequencies, different frequency applications. In that, you have any doubts are there? What are you facing the doubts and you are facing problems? Let us share after this lab. So today go for the coplanar waveguide feeding. So this is complete version change. You are in your PCs, you are using the HFSS old version, that is the 15 version. Now I am using the 19th version. That's why some little bit changes are there. Remaining all are same. So this is the, are you seeing my screen?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So this is the project manager. This is the design. Here we are, whatever we design here. This is the design window. So in this is the 3-dimensional. That's why I put the dimensions. The x-axis is x-axis. So the right side is the x-axis. This is the y-axis. So top is the z-axis. So simply here we are taking the, first of all, taking the substrate. So how to take the substrate? Already discussing previous class. So simply go here. Some shapes are there. These are the shapes or structures. So go to the box, that is the here draw box is there. This is the 3-dimensional 3D view. That's why click on this one, double click on this one. So place the cursor anywhere in the project design window. Now double click. So it will appear some box. So change the box dimensions and given to the substrate. So here this is the box 1 is there. Double click on the box 1. Here this is the box 1. Simply give the name as this is substrate. Give the name substrate. Material means that so many materials are there. So that's why generally I'm already saying last week FR4 is the in marketly available and cost is very less. That is the cheap costs. Go to the edit and search by name. That is FR for epoxy. So this is the substrate name. Search the FR for substrate. So clicking on OK and change the color. What you want to require the color, you can check the colors. Select the color. So this is the assigning the substrate. That means see previous vacuum is there. Now we are getting the FR4 epoxy substrate. So take the dimensions. So here the position, you take the position. I am giving the length of the substrate around 35 or 37 like that. Length and width are both same dimensions. Right now I am taking, for example, I am taking 23.5 to minus 23.5 and minus 23.5. So height of the substrate is starting from 0. Here x-axis is here the position starts minus 23.5. That's why substrate length, x is the length. That's why substrate length starts from minus 23 and with the double in the positive way. That's why double is 23.5. How much? That is the 47 is the
47.
And similarly 47. So this is the 37. Change this one. This is the 47, 20, 23. Okay, sorry. So substrate height is 1.6. So this is the substrate. So simply this is the substrate. I'm changing the color for your visibility purpose. So this is the substrate. So substrate length is 47. Can you check once again? So here line is there, draw line, place the corner. So from corner to here. So here in this window, measure window is coming. In that measure window, distance is 47 showing. That means position 1 is the reference value. So this is the minus 23.5. X is the minus 23.5. Y is the 23.5. Substrate is height is the 1.6. This is the position 1. This is the position 2 is positive value 23.5, 23.5, 1.6. So that's why the length of the substrate is 47 and the width of the substrate is also same 47. Okay, so then this is the, you see here rotation here. So this is the substrate, this is the FR4 substrate. The thickness or height of the substrate is 1.6. Then next step is design the patch on this substrate. So previous we are taking the rectangular. So now if you go for the another shape, that's why I'm taking the, here different shapes are there. See here, this is the rectangular, this is the ellipse, the circle, these are the polygon shape. So now I'm going for I'm choosing circular shape. So take the circular and click on the patch. Select this circular shape and double click on the patch. It comes the shape. So you can change the variable for this shape. Actually, so choose the color, the circle one. I'm choosing this color. Reduce the brightness. This is the patch color. So go for the dimensions. Here actually the center position. So this is the 0, 0. Top of the substrate is 1.6. That's why automatically coming 1.6. You can choose the radius is suppose for example I'm choosing the 12.5 mm and the position is in 0.6. That's why change the position from below to above. So this is the circular shape patch. Then it requires to give the excitation and feeding for this. So then we are taking the rectangular for the feeding. You can place anywhere and select this one. So here give the name as feed. Color. Your dimensions are 1.6. What are the dimensions given substrate? 57, 47. Okay. So for this circular and feed, there was no connection. That's why. So see here, there was no connection in between these two. So circular is placed as well as micro strip. This means simply a rectangular strip is also placing to give the connection between these two. So select these two. That means I simply click on these two. That is the click on the circular, press the control key and select the rectangle. Sorry. So select these two and go to the here. See here, some functions are there. Unite. Go for the unit. That means so this is the one shape is coming. That means you are giving the circular as well as the feeding. Then we give for the excitation for this. So this is the actually see here. So this is the 3-dimensional. This is XY. This is YZ. This is the ZX. So you will give the input here. Input in between the top and bottom. That's why here coordinate for the design purpose choosing the XY coordinate. That's why that was changed to ZX. So change the ZX coordinate and take one rectangular box and connected here. So this is the excitation. So for this excitation, I will give the name, already say the name, that is simply we are applying the port. So change the name rectangular to port. Change the color. Then apply the pink color. So this is the excitation. That means we are giving the input here. That means whatever the RF source, radio frequency signals applying here, the antenna excites, excitation based on this input. So this is the simple microstrip feed line technique. This is already learned in the last class. Now today class is the coplanar waveguide. Coplanar waveguide means simply I am saying here one strip line is there. In the strip line, left side one ground, right side is also another ground, but the separation is some gap is required in between the strip and left side ground and right side ground. So that's why you are taking taking here one rectangular box and taking the another one rectangular box here. That's why. So choose rectangular. So this rectangular is such a, okay, change the dimensions. Previous is the, for the excitation purpose we are giving the ZX. So that was changed to ordinary XY position. Take the XY, take the rectangular box. So this is the one ground plane. So see here, this ground, this is the very important point. This ground does not touch to this feeding and this circular disc. So here see the figure here. The design is we can maintain the gap between strip line, that is the excitation line, and the left side ground and right side ground. So that's why for your design purpose also you place the rectangular box, rectangular in the left side and right side. These rectangulars don't touch to the your patch, original patch. So that's why I simply give the name ground left side. That's why L, ground underscore L. Change the color and the color. Okay, we are placing the 0 value, taking the 0 value, guys. So take the 6. Bound is 3.5. So see here, this is the place the one rectangular, so that was not touched to the previous patch. So here some gap is there.
Can you show the dimensions again of the ground left?
Okay, I will. So you can see the ground position. Ground position I'm taking minus 23.5, minus 7, 1.6. Size of the ground is 21. X dimensions are 21, Y dimensions are minus 16.5.
Okay, sir, thank you.
So this is the minus here, minus 20, start from minus, what is the position, minus 23.5. So this length is 21, this length is 16.5. So same dimensions given to the right side. So taking another rectangular, placing anywhere, but dimensions you can change. So randomly selecting here, go to the rectangular. This is the ground right side. So ground right side, change the color. But the dimensions are, see here the position is 0 is there. That's why that was showing in the bottom. So but the patch is, substrate height is 1.6. That's why you can give the dimension 1.6 that will automatically come into the top. So previous for the ground one, for the left side ground, what are the dimensions? See here, minus 23.5. That's why left side is starting minus 23.5. Here right side we are taking the plus 23.5. Here minus 7, 1.6, 21 minus 16.5. So same dimensions applied into the right side ground. That one 23.5. So minus 7 the position. So 1.6 is the height. Dimensions minus 21. So this is the 16 point. Okay. Up to now, any doubts are there? Simply here you take the first substrate and assign the material FR4 and choose the dimensions. What are the dimensions for your convenient? That means based on the frequency. So I'm choosing the 47 length for the substrate. Width is also 47. Taking the one circular. The circular radius is also 12.5. Then connected to the feed line. So both are separate. That's why select on the unite. That's why this is one shape is just link between these two. That is applying the connect unite. Then take the ground plane in left side and right side. So see here in the previous, your main point is, so this is the excitation. Everyone visible this one? So in the microstrip feed line, the excitation, that means the input is only given to the center line. So this is the center line. But for the coplanar waveguide, these excitation also given to this left side portion, right side portion, and as well as the center line. So here some gap is there. So what means this is matching only, that means you are giving the input only to the center line. For in the coplanar waveguide, we are giving the input center line as well as left side and right side. That's why if you increase this rectangular size, this was touched to the left side ground and the center and the right side. So that's why I am increasing the dimensions of this pink color rectangle. So that's why simply click on this. So what is this? We are giving the port here. See the port. So port was blinking. So here generally whatever the dimensions are, generally we are taking minus 1.52. So we are varying the x value. That's why don't change the y and z. So increasing the x value. So simply observing. So this is the minus 1.9. So I am giving the 3.5. So here minus 3.5 start. That means so this is the minus 1.9. So minus 3.5 means some left side increases. So 3.5 is double is 7. So the rectangular size is automatically increases. That was touched to the left side ground, right side ground, as well as in the center. Is it clear? So in the microstrip feed line, we are giving the excitation only for the feed line only. But in the coplanar waveguide, we are giving the excitation for left side ground, right side ground, and center one. Is it clear? Any more doubts in this? So this is your design is completed. Then assign the frequency and excitations and a radiation box. So what is the next procedure? So we are did not assign the perfect T. That means these are the only shapes are completed. Did not assign the copper. That means we select on this one. Simply click on this one. Click on the right click. Go to the assign boundary. In assign boundary, assign the perfect E. So this is the perfect E. So click on this one. That means a perfect E assigned to the patch. So you can see the project manager. Go to the boundaries. Here, this one. So if you click on the perfect E1, it automatically visible. So like that. So assigning the perfect E for the ground left side and ground right side. Click on the ground left and right click on that one. Go to the assign boundary. Click on the perfect E. So previous one is the perfect E1 for the circular disc, perfect E2 for the left side. So left side is completed. Then that's why go to check here. This is the left side perfect E. So similarly assign the right side. So click on the right side ground, double click, go to the assign boundary, go to perfect E. So this is the perfect E for the right side ground. So here boundaries are completed. This is the circular disc or circular shape patch. So this is the left side ground. This is the right side ground. So already give the excitation. Given excitation or not? Okay, we will not give the excitation. So give the excitation. For the excitation, this is the XZ plane. That's why go to the XZ plane. So click on the excitation. So first select this rectangular box, then double click. So previous using the boundary, that is the assign boundary, but now go for the assign excitation. Excitation means just we are giving the input to source. Input source means generally we are giving the radio frequency signals. So that's why antenna already saying what is the definition of antenna means it converts radio frequencies into electromagnetic wave frequencies. That means converts RF to EM waves. So that's why for every antenna is it required to the excitation. So assign the excitation, go to the lumped port. Here so many are there. You can ask the doubts are what is the purpose of wave port, lumped port, flocate port, incident wave, linked field, voltage and current. For generally, so we are giving the 50 ohms impedance and some frequency. For in our function generator, whatever the frequency are there. So generally we are designing any analog circuits in electronic analog circuits in electrical labs or electronics labs. We are giving the frequency, that means AC signal. So radio signal, that's why we are giving to the lumped port. So wave port and flocate port analysis are different. So those are giving for another excitations, not for this. So generally assign excitation and go to the lumped port. Click on the lumped port. So here 50 ohms is coming. Click on this next, and the none is getting. That's why click on the none. Here go to the new line. Here some cursor is getting. So place the cursor exactly in below of the excitation box on the right side. So here arrow is getting. If you did not get the arrow, you cannot assign the input source perfectly. So if this arrow is getting, that's why click on this one. So that's why your input is given. Then is automatically come the defined. So click on next. So this is the finish. Your input is finishes. So design is completed. Boundary conditions also completed. We are giving the input. Excitation also completed. Then so choose the frequency. So that's why you go for the analysis. Here see project manager left side, here analysis are there, and go to the HFSS software. Here also analysis setup is there. So you can choose anyone. Go to the analysis setup, add frequency. So here setup 1 is getting, you can choose what are the frequency. So this is by defaultly you are giving any frequency, no problem. Either 1, 2, 3, 4 up to 10 or up to 20. So giving the 5 gigahertz and click on this one. So click on the right click. So add frequency shift. Add frequency shift means whatever the EM fields are getting by this antenna. So you can show the range. This is the range between curve. That's why select anyone. I'm going to the linear step curve. The frequency starts from 1 gigahertz and with 10 gigahertz. Step size, each size is 0.02 gigahertz. And set the, so see here, this is the sweep types. Are 3 types are there: interpolating, discrete, and fast. So if we get the accurate results, if we go for the discrete one, but it takes some more time and your system is have the high configuration system. If we go for the discrete value, and interpolating and fast is, so we are getting the, that means the processing time is less time. That's why I'm choosing the fast sweep type. Okay. So another one is did not assign the radiation box. So in HFSS 15, you are by defaultly clicking this box. So choose this box. This is the ZX direction, XY direction. So in HFSS 15, if we go for this box, so this is the radiation box. Choose the radiation and give the dimensions. Same, we like choose like as a how to choose the FR4 material, like that we can select the vacuum and give the radiation. But in the advanced version, so if you go for them choosing by default, so whatever the dimensions is required for this antenna, that software automatically takes and you get the accurate and better results. That's why, so I'm taking by default. Go to the HFSS, go to model. Here create open region is there. Click on the open region. So operating frequency, choosing any frequency. Here choosing the radiation box. Boundary is the radiation. Operating frequency is the 5 gigahertz. That's why choosing this one. So this is the radiation box. So here the better way means if you are using the advanced version software, choose the radiation box. That means whatever the dimensions is required for your design antenna, that it takes automatically. So this is the radiation box. So this is the open one. This is the radiation box. This is the PE1, perfect electric one for the circular disc. So this is the left side ground. This is the right side ground. Okay, up to now, any doubts are there in this design? This is the simply coplanar waveguide. So everything is completed. Then go for the checking, validation. So go to the HFSS software and validation. Click on the validation check. So all are completed. Design settings completed. 3D model, boundaries and excitations. Everything is completed. That's why it's getting the green color tick mark. Otherwise, is getting the cross mark red color. So everything is completed. Then go for the run. Go to the HFSS and click on the analyze all. Okay, saving this one. This is the so it takes some time. 3 to 5 minutes. So in this time you can ask anything, whatever facing your designing problems or any doubts.
Sir, I'm not getting how to check validation.
So validation, okay. If you go for, this is the window now in the top of the software. Here, file, edit, view, project, draw, modeler are visible. Modeler HFSS is there. So click on this HFSS. Here, click on this HFSS. Here, validation check is there. If you click on this validation check, so what is the error or what is the mistake in your design? It was showing. That is the validation check. After completion of the validation check, go to the analyze all. Simply you are using the MATLAB. Your MATLAB in the run option is there like that. Here also this is the run option. This is the validation check. This is the analyze all. So after completion, see here. So in the bottom, there is some window is there. Here window, here. So in the within the circle, very visible. This is the icon is getting the within the circle I shape, I symbol is there, and it is getting normal completion of your simulation server local machine is completed. So then go to the results. See here. So in the results here, project manager results are there, and go to the HFSS results. Here also results are there. For your convenient, so what you want, you can go. So this is select the results. Click on the right side, create model solution data report, rectangular plot. So for every antenna design, initially you can check the S11, that is the S parameters. In the last class, I am clearly explained why we are checking the S parameters. That means the scattering parameters. In 3-dimensional, we are checking the S parameters. That means we are giving the input. So we don't know. This is the simulation. Listen carefully. This is the simulation. That means you can design on the antenna. So these antenna, we are giving the input source only. In the simulation, you did not check the output. That's why how can you check the your validation, your design antenna is correct or not, means you are giving a input, so without getting the reflection back by the input. Understood? So your input is okay, S11 we are applying the input, that is the excitation. If the input is not getting back, that means the reflection is very less. That's why your input is excited and electromagnetic waves will travel into the free space. That is general concept. But in the this is the simulation software. That's why we can't see the output. So if you practically design the antenna, we are giving the current. So how much radiate into the free space, that is seen in the practical design. This is the software. So that's why we are checking the return loss. This is the simply return loss or reflection coefficient or S parameters. So that's why. So click on the results, right click, create model solution data report, rectangular plot. So this is the S parameter. So many parameters are there. That's the first initially checking the S parameter S11 dB. So already I am saying this value is must and should the minus 10 dB below. Same like as in our electronic circuits. How can you measure the bandwidth? Generally in the amplifiers, bandwidth is upper frequency and lower frequency. That is the difference between the upper and lower. That is simply saying the bandwidth. So and generally we are taking the minus 3 dB below value. Is it correct? So same like that, we are taking S parameter S11. So that is minus 10 dB level below. So generate new one. So here very less value is getting. Okay, I'm changing some little bit modifications, right? The radiation box, this is the close the radiation box. Wait a moment, I will check the Three point seven zero 47 1.6. Okay, can vary the some width length or better results. So see here. So what is the width? This is the feed length or feed width. This is the feed. So generally we are giving the 3.8 feed. We can change this one. 4. Once again run this. Suppose, listen, you did not getting the proper outputs. You can vary these dimensions. Already told you. So change the dimensions of this circular and change the dimensions of this left side ground and change the right side ground and whatever the feed. This is the excitation. So change the length and width of this feed. So, and once again you can run the observation. You can change. Previous you are observing the minus dB level is very less. That means around minus 13 or minus 14 getting. That's why I am changing the dimensions of this design. So it was computed. See here. So previous we are giving the input is excitation is 3.8. So right now that 3.82 I am changing the 4 value. The coefficient is almost increases. That is getting minus 10 dB below. Previous is only small curve is getting. So right now is getting the minus 30 dB. So this is the bandwidth. So click this one right side. Click on the right side, go to the marker, and place the marker, add marker. So this is your resonant frequency. So this is the resonant frequency, resonates at 1.62. So 1.62 we are getting around minus 30 dB. That means we are giving the input excitation to the antenna. That means reflections is very less. That means around minus 30. Minus 30 means it is negligible value. That is very low value. That's why your whatever the excitation given to your design antenna, that means maximum is transferred to the free space. That means RF waves converted to the electromagnetic waves, and that EM waves transferred into the free space. That means excitation here very less value. By giving the excitation, return loss is very less value. Okay, the bandwidth, how to measure the bandwidth means, see, observe here. So this is the minus 10 dB. So this is the minus. That means what is the difference? M2 here. M2 starts at M2 point is 1.96. M3 is the 1.92. That means almost how much? 440 megahertz. We are getting the bandwidth of this antenna. Okay, this is the return loss or reflection coefficient. Then go to the results, check the VSWR, go to the rectangular plot, select the VSWR, dB. Already saying VSWR, generally VSWR value is less than 2. So your resonating frequency is around, what the resonating frequency? Your resonating frequency is around 1.62. At 1.62, your VSWR value is less than 2. So that was checking. New start. See here. So this is the, click on right click, select the marker. So see here exactly at 1.62 resonant frequency, your value VSWR value is 0.55. So this is always less than the 2. That means, so check the S parameters and VSWR, both are excellent values are getting in the lower frequency 1.62. Then go to the gain and radiation pattern. So for that one, I am already saying how to check the gain and radiations. If you click on these radiations, right, delete this one. Any doubts are there how to show the results? So click on the radiation. First assign the, here see, insert far field. We are already studied in antenna design. So you are saying in the antennas theory, they are saying, the faculty saying induction field, far field. What the terms, that one? Induction field, far field, radiation field, 3 terms are there. In the derivation you find out the electric field and magnetic fields. 1 by r term, 1 by r square term, and 1 by r cube term. So generally in the radiation, in antennas, generally considering the far field radiations. That's why go to the insert far field setup, click on that one, assign the infinite sphere. So in that infinite sphere means it is a 3D. In that 3D, we are giving the phi value and theta value to show the radiation pattern as well as gain, generally calculating in terms of phi and theta. If you choose the phi equal to 0, that is the electric field plane, that is the E plane, and phi equal to 90 degrees, that is the H plane. In the electromagnetic or any electromagnetic wave, EM wave, electric field and magnetic field both are perpendicular to each other, that is perpendicular to each. If the electric field exists in the x-axis, automatically magnetic field exists in the y-axis, that is the in between these two 90 degrees phase is required. So that's why for that purpose, if you check the radiation patterns and gain, if you select first assign the radiation, so that is available in the project manager last column. So this is the radiation. Double click on the radiation. So give the phi values. Generally phi values is use 0 to 360, that is the complete rotation. One cycle 0 to 360, and the theta value choose minus 180 to 180. Note down this point, everyone. So if you check the radiation pattern and the gain of your design, so go to the project manager last column, radiation is there. In that radiation, click on right click. So go to the insert far field. In the insert far field, infinite sphere is there. Click on that infinite sphere. So choose the phi values 0 to 360, theta values minus 180 to 180. So click on this one. So this is the infinite sphere completed. Then go to the results. So previous, whatever the reflection law S1 per parameters or VSWR is create model solution data report rectangular plot. But if you go for the radiation pattern, this is the another option there, create far field reports. In that far field reports, we can go to the radiation pattern and click on the radiation pattern. So this is the radiation pattern showing gain total are simply dB. Click on this one. Here getting the last adaptive. In the last adaptive showing, click on this last adaptive, getting the sweep. So go to the families. Here are families. What is the resonant frequency? Our resonant frequency is 1.62. That's why you can choose the resonant frequency 1.62. 1.62 is our resonant frequency. So this is the 1.62. So I'm already saying. So if you saw the E field and H field, so choose the phi value equal to 0. So click on this phi, choose the 0 degrees. This is the 0, and then press the control and select the 90. 0 and 90, it shows the both electric field and magnetic field. That means simply E field and H field. So generate. This is the radiation pattern in 2D, two-dimensional. So this is the radiation pattern. So red is the E plane. Red is the E plane. So this is the maroon color is the H plane. So listen, how can you say this one is best shape? So you already studied radiation pattern, different radiation patterns. You heard the name omnidirectional radiation pattern? Say or not? Omnidirectional radiation pattern or isotropic antenna. Omnidirectional radiation pattern means whatever the fields exhibited by the antenna, that fields are equally directed. That means equally radiated in all directions. That is the omnidirectional. So you can design any antenna that was getting the omnidirectional pattern. That antenna is better antenna, not better, that is the excellent antenna. So you design, that means see here, this is the red shape is almost is the circular shape, and H plane is like as a 8 shape. So E plane and H plane you are getting the circular and 8 shape. Your design antenna is working for excellent values. That means you are getting the excellent values in the, especially in the radiation patterns. So this is the radiation pattern. Similarly, go to the check the gain, create far field report, go to 3D polar plot. So gain total dB. So same like this, go for the sweep. So families here, frequency is our resonative frequency is 1.62. So this is the gain in 3D. So this red part is maximum gain. So this is the gain in 3 dB. We are already seen in the textbooks in antenna design. Balani's textbook, so many shapes are there showing. So this is the gain. So almost maximum part is the red is there. That's why this is the maximum gain. How much you are getting? A 5.34 maximum gain you are getting. So you can check the 4 parameters. The reflection coefficient, that is the S parameter. This is the S parameter. We are getting the resonant frequency at 1.62. Bandwidth is around 440 megahertz. And VSWR. So VSWR at our resonant frequency 1.62. The value is less than 2, that is the 0.55. This is the radiation pattern. So this is the radiation pattern. So almost omnidirectional and figure 8 shape getting. This is the better radiation patterns, and this is the gain. Okay, any more doubts till now? So this is the coplanar waveguide feeding. So simply coplanar waveguide means we are placing the one rectangular in left side and right side of the main strip line. This is the, see here, this is center is the main strip line, and left side is one plate, right side is one plate. But we're giving the excitation for all. See here, this is the very important. So whatever the excitation is giving, this excitation touch to the left side plate, center and right side. So this is the coplanar waveguide. That's why I already explained the theory. So see here, this is the substrate, this is the substrate, this is the left side ground, this is the right side ground. So this is the strip line. So we are giving the excitation here. That excitation touch to the left side ground, right side ground and center. This is the coplanar waveguide. So this is one type of excitation, or simply one type of input. So compared to, listen, what is the advantage of this feeding technique compared to the previous one? Anyone is observing for this? What we observe in this technique? Previous design, last week design, and in this week design. Anyone? What we are observing? Who can say? Are following or not? Hello?
Sir, in the previous one, the ground is below the substrate.
That is
Here,
okay.
ground is above the substrate.
Above the substrate. Above the substrate means a top layer. So listen,
Yes, sir.
that is the design consideration. But here,
Sir, in this excitation is given to multiple sources, sir. In that only we are given only to one side excitation.
okay, but you did not get any accurate point. So previous, the bandwidth is very less. Only small spikes are little bit spikes are getting observing or not. But here you are improving the bandwidth of your antenna design if you go for the coplanar waveguide. So simply you can observe previous what already you designed the microstrip feed line. The bandwidth of the microstrip feed line is less. When you go for the coplanar waveguide, the bandwidth is automatically increases. See here. So this is the bandwidth is almost 440 megahertz is getting. If you done the parametric analysis means you can change this circular disc dimensions. So generally I'm placing the 12.5 I'm choosing. You can place so in between 11 to 13. You can change it by suppose 12.5, then 12.3, 12.1, 12, 11. You can observing. So at a particular value, automatically values are increases. That is the best values and that is the optimization. That is variable method. Understood? So you can change these dimensions and you can change this left side ground, right side ground, and everything you can optimize. Optimization means maximum value. At what value you are getting the better results. So that is the optimization. If you done the optimization for all the parameters, that means bandwidth is automatically increases. So compared to the microstrip feed line, what are the advantage in the coplanar waveguide means? So simply adding the ground in top of the layer that was not touched to the feed line. So here see, so that is gap is there. So don't touch to the circular disc and bandwidth is increases. This is the advantage point compared to previous one. Anyone doubt? So otherwise you can leave.
So is it possible that different versions will show different kind of results?
Different versions means software versions you're asking?
Yes, sir.
No. Software is same. That means upgrading. So same you can set these same values in your HFSS 15. The value, the result is same, but the upgradation is available. That means advanced features are there. Some in HFSS 15 by default did not assign the radiation box, but here radiation box are there. Some extra features are there compared to 15 version. Software is not.
So is it better to update it to 18?
18 is available.
Okay, sir.
Okay. 21 is also there. Latest is that 21 is came. 21 version is also there. So this is the just versions. Okay, so if you upgrade the software, that is not getting the accurate results. That is not good. That is not the correct point. So whatever the software is no problem, but some extra features are getting. Yes, olden days only simple Reliance phone using, that is the only voice is there. Then coming to voice to audio, then everyone is getting that is upgrading is there like that. Version upgrading is there. So everyone you can try. So without practicing these designs, you are facing problems in the external exam. So what I am saying, you just listening and practice that designs. So not take this particular design. You can design any shape. Whatever you are getting the shapes, you can design. And if you can any problem, you can ask me. I will explain what is the problem, how can you remove that problems, and how to overcome the problems. So nowadays, so many members working in this HFSS software. If you never
Sir, may it possible? Hello, sir.
okay, but
If we run, we getting frequency points. It is possible to get so many frequency points or so more options to find bandwidth.
okay, that's why I'm saying that if you're getting the more frequencies and more bandwidth means if you are that means here. So this is the design. You can apply the some shapes. Suppose simply I'm taking the circular shape. In circular shape, just we are placing simply, we are placing any little bit small rectangulars. So small, that means small rectangulars on the circular, above the circle, the corners of the circle. That shape is changes. That means simply if you change the, simply we can design like a corona shape. We recently getting a one. So that means, so here showing the very small. So this is the rectangle box is high, right? We can show the small rectangle boxes in different places. Suppose here two rectangular boxes, here two. Placing any additional in this patch, so automatically increases the bandwidth, automatically increases the gain, automatically increases the resonant frequencies. So I am saying simple designs. Understood? Okay. Can now close the lab. Any more doubts?
Sir, can you show the radiation box dimension?
Radiation box dimensions.
Yes, sir. Please.
I am choosing the by default now. That's why here radiation box dimensions not visible. Vacuum. Okay. 20 in all directions. See here.
Okay, sir. Thank you.
Plus x na, plus x, this is the 20 in all directions. 20, x is 20, y is 20, z is 20. Okay, this is I'm choosing randomly, that is in the advanced version. In HFSS 15 we can choose the by default, not by the default, choose the radiation, go to the 3D radiation box, draw 3D model box and give the dimensions x equal to 20, y equal to 20, h equal to 20. So this is the radiation box dimensions. So otherwise you can note down any one. If you note down the circle radius, circle, this is the circle dimensions. Circle position is 0, 6, 1.6, radius is to 12.5. And this is the feed, that means connecting the feed width, feed length. This is the feed width is 4. Previous I am by default choosing 1.9 here, 3.8 is given. So for the 3.8 not getting the accurate value, that's why I'm changing 3.8 to 4. You can change 4 above also, 4.1, 4.2. So you can increasing the value, that's why you can fix the, at what value you are increasing the parameters, you can fix that value. Okay. All of you, if any more doubts are there, the persons are staying and ask the doubts, and remaining persons leave the class. You are third year students or second year students?
So 30.
Okay. Total strength is
118.
what?
So 118.
That is